do with this is up to you. Before we can do today's stuff, which is the last thing you will notice in this whole unit, you must be good at basic algebra. When I say basic algebra, I mean basic algebra. So I'm going to quickly use the top of this page to do some basic algebra. If you don't feel you need to see it, don't write it down. But at the very least, pay attention and keep quiet so you're sure. At the bottom of this page, because I printed this page like an idiot, I wanted this to be down here so I could write the notes over here. But it printed, I'm a moron, so we're going to have to do our lesson part down here. Sorry. We'll get to that in a minute. But before we go on, as previously mentioned, every single one of you can do this in your head. Not one of you will write down the work. Of course, you should write down the work because if you write down the work on the easy ones, then the hard ones are easy. But again, you don't have to write it down. You could just think in your head, I would do this. Okay? All right. It's going to be very easy. You are all going to yell out the answer in 2 seconds. Then I'm going to ask a second question, and I want you to think very carefully before you yell out the answer to my second question. Clear? Okay, here is the first question. All you're going to do is tell me the answer. What's the answer? Okay, that's the first question. Here is the second question. Why? Just say it. Just say it. Wrong. I was waiting for somebody to say that. If that is all there is to algebra, then every single one of you would be able to tell me the answer to this question. Right away. But you can't, can you? Okay. So, Crystal, you were right. Everybody who said, because 2 plus 7 is 9, even if you thought it, is wrong. Okay? Crystal is right. This is 2 because 9 minus 7 equals n, and 9 minus 7 equals 2. Okay? We all remember basic algebra, yes? Okay, I would like to make sure of that. Can you solve that? All of you should be able to solve that with no problem whatsoever. Like it should barely flex your math muscles. That's like bench pressing just the bar. Or doing dumbbells with those little wussy 1-pound weights that they put in the set you buy from Walmart so people think that they're getting fit, but they're not. You know those ones. The ones that are lighter than a chunk of butter, like you think you're really exercising. Those ones. That's what this is. Is everybody good? Everyone's got an answer? What is it? It is positive 3. Okay? Everybody should have been able to do it. Of course, what you probably did, hopefully, was get to 3n plus 7 equals 8n plus 6. Then I hope you went 3n plus 21 equals 8n plus 6. Then I hope you went negative 5n equals negative 15 and n equals 3. I hope. Something like that. Some of you may have had a different path to get there, but hopefully you all got there. Yes? Do I really need to spend time going over algebra? Excellent. So now, slide to the bottom of the page. At the bottom of the page, I would recommend drawing a line. Now, what about this equation is reminiscent of this equation up here that you just did? What's the same? Mandarin. Excellent. It's got all the same stuff, but there's a radical, right? What's the goal in every single piece of algebra? Oh, Manrup, you're on fire. No. Joseph, to isolate the variable, yes? Okay. Yeah, I know, right? He's like this, and then he's like this, then he's like this. He's a wild man. He's the man Rupert coaster. Rupert coaster, nothing. Roller coaster, up and down. Man Rupert coaster, no. That was no good. I thought it was good. That was a strikeout. Don't write that one down. All right. So, yeah, right? Your goal is to isolate the variable, yeah? Now, you will notice something about question 1 there, yes? Where does that variable live? Under a radical. So now, Manrup, if the variable is where we have to get to, and it's under the radical sign, what do we got to get rid of? Yeah! We got to get rid of the radical sign. He's back up here. He is like a roller coaster. Okay, so when we are dealing with radical equations, what's the only part of it that makes it not normal? What is the only thing that makes it different from these ones that we learned about in like grade 6? It's the radical sign, right? So logically, what should we try to get rid of first? The radical sign. So, whenever in algebra you want to get rid of something, you must do what to it? The opposite operation of what you see, yes? So you're smart kids. If I have a plus 7, what must I do to get rid of it? Subtract 7. If I have a divided by 3, what must I do to get rid of it? Multiply by 3. If I have a square root, I did the emphasis wrong there. If I have a square root, what must I do to get rid of it? Square it. Huh? All right. So obviously, because we're super intelligent young people, step 1 in all math is always, what is going on, you piece of garbage? Where's my ribbon? Ooh, I hate you. I hate you, I hate you, I hate you. Ooh, I doubly hate you. George is getting very upset. You wouldn't get that if you're not a Seinfeld fan. But Seinfeld is soon to be on Netflix, so I expect every one of you to start getting all of my Seinfeld jokes very soon. There's 200-odd episodes. I expect you to have them watched about 2 or 3 days after it comes on Netflix, because I know that all you do is binge watch everything. Many of you have not. Ashley, it's like 3 days to watch 200 episodes? Please. I do that in a... I'm aware of that. So, there's actually 6 seasons.
No, that was the new season wasn't out yet.
Oh, okay. All right, back to business. Where was I? I was on a funny roll. What was I saying? Oh, Seinfeld. George was getting very upset. Right, that's not math. Back to math. Logically, what is our first step? Should be to eliminate the radical, yeah? To eliminate the radical, I must square it, yes? Now, would you rather... Don't write this down. Would you rather square that, which would mean you would have to write x plus 7 plus 3x minus 5, and then do triple distribution, or would you rather square that? Choice A or choice B? Choice B, obviously. So we know we've got to get rid of the radical, but we don't want to square a bunch of stuff that we don't have to get rid of. So what should be the first thing we do? Close. We only want to square one thing, right? Isolate. Step 1 needs to be isolate the radical. Now, you're smart kids. Can there be a radical on both sides of the equation? Do you think? Yeah. So we might have to isolate radicals. And we would achieve that by working with, so I should have written working. We do this one at a time. Everybody cool? Now you'll notice on this first page, there is only one single radical all the way through, yes? Because that's practice, right? We start easy and we build up. Don't turn the page, Preston, you'll be like, arr! Don't do it, man. Just stay cool, stay with me. I'll get us there, brother. I will get us there, brother. That was my grip to pull you through, but you didn't reach over, so I'm a little hurt. It's okay. So we're going to isolate the radicals. Now that they're isolated, we're going to eliminate. How? In this case, it's all square roots, right? So how are we going to eliminate it? We're going to eliminate the radicals by squaring. If we square the left side of the equation, what must we do to the right side of the equation? Square it as well. By squaring both sides, he said in a... That was not Admiral Akbar. That was not Admiral Akbar. Maybe it was. That was what I was going for. I wasn't going for Admiral Akbar. Now, once the radical has been eliminated, what will we be faced with? The rest. So once the radical's gone from all those equations that you can look at on the page, what's our next goal? Obviously. To isolate the what, Sahil? The variable. Oh, Sahil, you're on fire now. Move over, Manroop. Holy. It's the... Trying to think of a carnival ride that would work with Sahil since I ruined Manrooper Coaster. Sahil, the Tilt-A-Whirl, no, that doesn't work. The Super Sahilide? No, because that's only going down, and he's on his way up. The Sahilevator! Huh? Because he's on his way up, like the rocket. And now, don't answer the next question wrong, because the next thing on the elevator is you drop down. So, but we'll see. Okay. And to think, some of you were thinking you would skip last block today. What a silly mistake that would have been. Isolate the variable using regular algebra. And step 4. What? I see. Wait a minute. Yeah, step 4. Now. Must. 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 Must.
Oh, right. Or do you have to?
I'm not done yet.
Is it necessary?
I'm not done yet. Exclamation point, exclamation point, exclamation point. And wait, for my Brazilian friends, I think they do this in Portuguese as well. Upside down exclamation points at the beginning. Because that's how, do they do that in Portuguese? They don't? That's only in Spanish? Damn! Well, let's pretend you guys moved just one country over. You choose the country. I don't care. You could be in Venezuela, but right now. You could be what's right south. You could be in Argentina. That would be fine. Although, again, bad economy there right now as well. Paraguay? Oh, a lot of German in Paraguay. Uruguay. Uruguay's all Spanish. We'd go to Uruguay. Mind you, all the rest of them in this room are like, he knows more than one country in South America? Exactly. All of you were like, what continent is he on? Uruguay's not in Europe. I've seen the map. I've taken social studies. Anyways, Uruguay, big country, huge country, not landlocked. Capital's Montevideo. I played a lot of Where in the World is Carmen Sandiego when I was a kid. You all watched the Netflix cartoon, but back in the day it was a video game and it was super fun. It taught me so much stuff. Anyway, now, Ashneet, please, sir, do this question, or do this option. You must check your answer in the original equation. Now, why did I do all this stupid stuff? Because ain't one of you ever bothered to check your work. You always ask, Mr. Mize, I do this right? Did you check it? No. Check it. Yeah, I did it right. You have to do this here, and you're about to see why. I know you haven't believed me. For some of you, in 2 years since I taught you, you've never checked your work once, and I always say check your work, you never do. But in this point, you have to do this step, okay? All right, so let's go. We're smart kids. Yeah, we are. Now, we're going to do something really horrible, and we're going to ignore the instructions right now, because these instructions are something I haven't even taught you yet, because it's something new. All right? I want to get through the algebra part of this before I deal with restrictions. Everybody all right with that? You don't really have a choice. You know what I'm saying? That's what I'm doing. I am the boss of you for the next hour. Then you're free. So, in black, because I'm going to color code, what should I do first? So what's in the way of the radical being all by itself? That 5. Now, if you've done a lot of math, maybe you just slide this 5 over here and do minus 5. Maybe you're a little like, oh, math scares me. It's the Pennywise of my universe. Maybe you need to do minus 5, minus 5. No shame. No shame. You go ahead. You do what you need to do. But your first step should show root 2x minus 1 equals 12 minus 5, which is root 2x minus 1 equals 7. Huh? Okay. What's the next step, which I believe I have in red down below? Eliminate the radical. In this case, all we need to do is square it, yes? Now, some of you are going to make a mistake here. What am I going to write right here in red that shows the left side of this equation the way I want it to look? Manru. Oh, come on, buddy. Joseph? 2x minus 1. It is not a conjugate situation. We are not trying to eliminate anything but the radical, right? If we knew what x was, then this would just be one single number, wouldn't it? Okay, good. And what does that equal? 49, lovely. And then in blue, I now isolate the x, yes? Or the m, or the p, or the q, or the z, or the fish, or the lightning bolt, or whatever the variable is. So let us do so. 2x equals 50. X equals 25. Are we good? Everybody can do this, yes? Now, what is the fourth step that I said you must do? You must check in the original equation. And when I do this check, all of you are going to be like, why? It was right. I don't need to. And then when we do the second one, you'll all be like, I'm not going to bother. And then, I'm giving it away, you'll all hand it in and I'll mark it wrong. I won't give you 0 because I'm not that teacher, but I will be angry with you if you don't check it. Okay? And you'll see why in a second. Everybody good to go? Let us go, carrots. So 5 plus the square root of, what is 2 times 25? 50 minus 1 equals 12. 5 plus the square root of 49 equals 12. 5 plus 7 equals 12. Huh? Does 12 equal 12? So did we do it right? And now all of you are like, I can do this. I don't need to check it. All right, I have given you a very fierce finger wag. All right, now let us talk about this. What does the word restrictions mean in English? You can't do it. All right? Somewhere in this equation, there's a spot where certain numbers are not allowed. Do any of you see where that spot is? Where in this equation is there a whole bunch of numbers that aren't allowed to be there? Satjo. Under the radical. What is never allowed under a radical sign? A negative, right? So x can be any number in the universe as long as that is positive, right? So how do we check for that? We take the radicand. What if there was more than one radicand? Would I have to do this more than once? Yes. I take this radicand and I'm going to use yellow to keep the whole yellow theme going. 2x minus 1 must be positive, yes? So it must be greater than 0. Everybody understand? Which means 2x must be greater than positive 1, yes? Because we all remember grade 9 when we learned inequalities. And x must be greater than 1/2. Is x, which is 12, bigger than 1/2? So we know we're okay. Everybody good? Now, I said I was not going to do the restrictions at the beginning, right? Because I wanted to make sure we were good with the algebra. But when should we really check for the restrictions? At the beginning or the end? At the beginning, because if our answer doesn't fit in those restrictions, we're done. We don't need to check it, do we? So, over here, how are we going to check our restrictions? Where am I going to look? Under the radical. And what do I do to check those restrictions? 5 minus n must be greater than 0, yes? Right? So negative n must be greater than negative 5, right? And then n must be what? Less than positive 5. Because when you divide by negative 1, you flip the sign, which you all remember from the 9th grade, right? Okay, might need to do some inequality work in a little bit, but let's worry about that later. So what am I going to do here? In black, I need to isolate that radical, yeah? So what are we doing? I would take this whole thing and move it over here, because what would that do to that negative? It would make it positive. And then what would I do with that negative 7? I'd move it over here, and what would that do to that negative sign? I would get n plus 7. Everybody good? What's step 2 that we do in red? Sacho. Square both sides. Square, square. What is on the right now? 5 minus n. What is on the left now? All right. We're back. N squared plus 14n plus 49. Because the whole side needs to be squared. Aight? That wasn't too bad, class. Now, this is ugly, yes? You may not know what to do here. But you bring all of your math to the party, because this, I told you, this page has every single thing you've done in high school math on it. Almost. I see an N there, I see an N there. What should I do? I should combine them, shouldn't I? They're like terms. So I'm going to bring this N to here. Why? Because I'd rather move one N than 14 N's. N's are heavy. Nothing? It's a joke, because you always want to move the smaller one. What do I see there? What do I see there? A 5. What do I see there? Aren't they like terms? So should I collect them? What did I leave here? Nothing. Now some of you are still going, well, I don't know what to do. So you think to yourself, is there something you see here, and I'm highlighting in blue because we're going to start doing the blue step now, that looks like something else you've seen sometime in your high school math career? Sat joke, bring it home. Factor it. Because you know what to do with that. You don't know where you're going, but you know that that factors. So what is it? And now we're still at a weird thing, because you haven't seen this unless you were in my Honors 10 class. What math, well, just being there doesn't necessarily guarantee it. Right? Right. What math is happening right there? Multiply. So in order for this to be true, if this equaled 0, or if this equaled 0, would this line be true? It would, wouldn't it? So, either n plus 4 equals 0, or n plus 11 equals 0, which would mean, isolate your n equals what? No. -4. Or n equals -11. Is everybody cool? I know there's another way to do it. Do I have two answers now? Previous to this, all of you would stop here. N equals -4, -11. Got it. But you must check. Let us discuss why, cabbages. First, are both of those numbers less than 5? So we're okay, right? All right, here we go. So now, in green, we're going to do our check. In the original equation, with this guy, -4 minus the root of 5 plus 4, because minus 4 is plus, yes? Equals -7. -4 minus the root of, what's this? 9 equals -7. -4 minus 3 equals -7. Is that true? Is -4 minus 3 -7? Yes. So is 4 a right answer? Indeedly-do. Now, with a different shade of green, let us check this one. -11 minus the root of 5 plus 11 equals -7. -11 minus the root of 16 equals -7. -11 minus 4 equals negative 7. Is that true? No, of course it isn't, because that's negative 15. So 11 is not an answer. Now, listen to me carefully. Some of you should be saying, why? How can you have two answers that one of them isn't an answer? How is that possible? I will explain to you how it is possible. 25 equals what squared? 5, right? $25 equals negative what squared? 2 answers, right? When you square something, you open up the possibility of another answer, which is why we have to check them all. Everybody understand? Because if I don't square this, then there's only one answer there. But I gotta square it in order to find the answer. Everybody good? All right. We're going to do 2 more and then we're shutting up. So this one's pretty easy. Is the radical already isolated? Oh, but what did I forget to check for first? Restrictions. Restrictions live under there. 2 minus p must be greater than 0, yes? So, negative p must be greater than negative 2. So p must be less than 2. P, and I'm writing in yellow. That's what makes you guys laugh. P jokes. The rest of the stuff has been gold. Gold. But a P joke? Farts. What's she doing? Why? Because the P joke was that funny? Relax, Jasleen. I got 1 million of them. Literally gold, yes. Golden. If you peed gold, that would hurt. I think they've stolen my pee joke and made it different. Yeah? All right. Back to business. I'm choosing to never mind, Joe, and I'm thanking my lucky stars that the microphone isn't that sensitive. So, what do I need to do now that I've done my restrictions? Square both sides, because the radical's already isolated, right? Now what? Now what? Factor it. To what, Henry? P plus 2, P minus 1 equals 0. Now what are my options for P? Standing or sitting? What are my options for P? Stop it! Stop it! What are my options? -2 or +1. Are they both lower than 2? Yeah. So now I check in the original equation, yes? So I check with negative 2. Negative 2 equals the root of 2 minus negative 2. What is 2 minus minus 2? 4. Is the square root of 4 negative 2? We have an argument here, yes? It can be. Now this is where I tell you that this symbol means we are seeking the positive root, which has a special name, the principal root. So this, while technically right, is not what we are seeking. Everybody cool? So this is wrong. So is negative 2 one of our answers? No. Let's check 1. 1 equals the square root of 2 minus 1. 1 equals, what's 2 minus 1? Square root of 1. What's square root of 1? Does 1 equal 1? In my universe, so that is our only answer. Does everybody understand? You try D. Yes, Jose. I don't care. I couldn't care less. Yo. Yeah, you go. All right. I'm going to write out this answer, and then you can compare your work to mine later on. Yo. Yeah, go. Are people ready? No rush. Okay. We good? Does everybody feel they have an answer or two? Now, all I have done, ladies and gentlemen, all I have done is scooched to this question when I did it before. I haven't actually written out the answer. Okay? So even if you watch the video, you won't see me do it unless you ask right now. There it is. Now, I made an egregious error. I forgot the equal sign when you were checking restrictions. Because does 0 have a square root? 0 times 0, right? So it's not just greater than 0. It could be greater than or equal to 0. I forgot that. Huh? Everything under the radical can always has to be greater than or equal to 0. I forgot the equal.
Okay, is that for all the other ones as well?
Yeah. Always. So everybody should be able to follow this. So everybody should have been quite comfortable arriving here. Right? Everybody should have been good to get there. Yeah? Then all we do is check. Negative 3 times 6 is negative 18. Negative 18 plus 19 is 1. Negative 3 plus 2 is negative 1. Square root of 1 is not negative 1 because we seek the positive square root. So 3 is dead to us. 5 is our answer. Now, I was trying, ladies and gentlemen, please, I have been trying to avoid throwing vocabulary at you. Okay? Because the math is the important part. But everybody should be okay here now, right? We haven't done anything really new. It's all been principles we understand. Do the opposite of what you see, factor, right? We should be good, right? And then checking, we're just substituting n in for n. This is all stuff we know how to do. Now I'm going to throw you a new word that you haven't heard yet. These answers that are answers but not really answers are what we call extraneous roots. Because they're not actually needed, because they don't work. Everybody cool? So because that 3 doesn't work in the original equation, it only works in the version of the equation where we squared it, it's called an extraneous root. It doesn't count. All right? Everybody okay? All right. Now, I'm going to stop, and no, I'm not going to pause the recording. I'm going to stop, and your job on Monday is to attempt E, F, and G. I will be back before the... Oh, wait, you guys are first block, yes? On Monday? I may or may not be back that first block. If I am not back, I will put some more... No. Before I leave today, I will put some more of these on the board. Easy ones. Not easy ones, but ones like we've done. All right? If I'm not back, gentlemen, if I am not back, it is Miss Craig that will be in here. I love Miss Craig more than anything. Yeah. Okay, so don't stress her out. She is doing me a huge favor. If Miss Craig saw this, she'd be mad that I would leave her and say, do this. Just like I couldn't drop into the middle of her class and pick up exactly what she is doing. I could talk about Englishy things, but I couldn't pick up exactly where she is. Okay? So don't expect that. If I make it back, spectacular. If I don't, you are making sure 67 and 68, whatever it was, is done. Because we're marking that. and you are attempting...
65 and 66.
Okay. Yeah, we're on 67 and 68. You are attempting to finish 68, and just to be safe, I'm going to put some more up there, like 4, that are like this, with radicals, only one radical on one side. Except you'll notice something weird's going on here, right? Haven't actually taught you how to do it. But again, I would be very happy to see you figure this out, because you do know how to do it. Okay? Everybody good? Yeah, go. All right? Everybody okay? Everybody understands what's happening Monday morning? Okay. Now,